Hello everyone, today we're going to work on a servo motor controlled by a photoresistor. The purpose of this project is to have the servo motor turn from and back to its original position depending on the brightness and the environment. Sounds like it could be applied to different areas, right? The materials we're going to use are an Arduino Uno, a breadboard, a servo motor, 3-pin photoresistor sensor from the 37-in-1 sensors kit for Arduino, and 6 jumper wires. Now that we have all the needed materials, the following step is connecting the circuit. Starting with the servo motor, use 3 jumper wires to connect it to the Arduino Uno. The yellow pin on the servo motor is supposed to be connected to pin 9 of the digital input-output pin, while the red one is supposed to be connected to the 3.3 voltage pin and the brown one to the ground pin on the Arduino. Use 1 jumper wire to connect the orange wire to the digital pin 9. Use another jumper wire to connect the red, which is the middle wire, to the 3.3 voltage pin, and use a third jumper wire to connect the brown wire to the ground pin. Next is a photoresistor. Connect the photoresistor to the breadboard on any pins of your choice. Using a jumper wire, connect the photoresistor's negative pin to the ground pin on the Arduino Uno. After doing that, take another jumper wire and connect the photoresistor's positive pin to the 5V pin on the Arduino Uno using that jumper wire. And then use the final jumper wire to connect the S pin of the photoresistor to the analog 0 pin on the Arduino Uno. Compare your circuit to the circuit diagram shown on the screen to make sure that it's well connected before moving on to the next step, which is writing code. Open the Arduino IDE and create a new sketch. In your sketch, start by including the servo library and create a servo object. Then declare or define a variable for reading in data from the photoresistor sensor, as well as one variable for the servo motor angle. In setup function, start the serial communication and attach the servo on pin 9 to the servo object as shown. You can also include a print statement to mark the beginning of your program if you would like to do so. In the loop function, include a line to check the photoresistor readings if you would like to show them. Have a conditional statement that runs if the sensor value is at a given point. That is a conditional statement in which the servo turns 180 degrees from its position and 180 degrees back to its original position. Include delays as you see fit. After finishing writing your code, connect your Arduino board to your computer using a USB cable. Select the correct board and port from the Tools menu in the Arduino IDE. Click the Upload button to compile and upload the code to the Arduino board. If your program is not working, here are some debugging tips. Make sure you have selected the board Arduino Uno before uploading your code. Make sure the servo library is included in your code. Make sure you typed in the right keywords and variables because Arduino is case sensitive. If you don't see any output, make sure all the pins are well connected. To test your code, you can use the serial monitor to check the photoresistor's readings and know how you can edit your code to have more noticeable results. You can also cover the photoresistor to reduce or increase the brightness and see how it affects the servo. Here is a fun task for you. Now that your photoresistor controlled servo is working, can you think of ways to design another circuit that is also controlled by the photoresistor? You could also try photoresistor controlled LEDs or try a completely different circuit controlled by another sensor of your choice. You could also just play around with the code to understand it better.